I found a way to adjust the auto exposure, so now I have proper colors. Hello and welcome to another Solana tutorial. Today we're gonna talk about compressed NFTs again, and we're gonna dive a little deeper into the details because a compressed NFT is not actually a compressed NFT. And I don't just mean that by the naming. I mean, we're gonna change the naming to collectables or digital assets or whatever the culture demands. But I mean that in the sense of a compressed NFT is not equal to another compressed NFT because some compressed NFTs are just not composable, whereas others are. And today we're gonna have a look at all those nuances because knowing about that is important. When you create your own compressed NFT collection, you need to know about those things because they have consequences. Because a compressed NFT is not equal to a compressed NFT. That was the case with regular NFTs. If you mint a regular NFT and you buy it, then you can be sure that it's that kind. Like every regular NFT can be burned for that amount of SOL or whatever, right? It's always been the same. I mean, yes, the standard changed. Some are editions, some are PNFTs or whatever, but they've always been on the account. There's always been that metadata. Now with compression, that gets way more complicated because for a compressed NFT, it depends on the tree that it resides in. And as we learned in our first video about state compression, those trees can differ a lot. But let's start with some background and my motivation why I'm here. Now, Tensor, not a sponsor of this video, but a great marketplace. They have been shipping compressed NFTs. So I can't point that far. But this icon they're using to mean compressed NFTs. So this is the emoji for compression. I mean, there's no better way, right? So those are all compressed collections. In case you ever see that in somebody's Twitter bio or Twitter name. For instance, in my Twitter name. Anyway, so Tensor has released compressed NFT collections yesterday. And then I was like, hey, can you add mine? And literally 2 hours later, they actually added mine. Look, it's here. There's my NFT. I mean, we gotta work on the name. That's too long. But see, actions have consequences. When I was minting that collection NFT, I was like, yeah, whatever. It does not really matter what I put there. It does not matter which picture I put there because it's not gonna be shown anywhere anyway. Boy, was I wrong. It is shown. It is shown right here. Look, it's right. That's my face. I mean, the rainbow colors, I kind of like it. Fits to the months of June. But yeah, the name, I could have picked something better. And we're going to change that because we don't want to name them cNFTs. I would like to call them Solandy Clips or whatever. And they are my YouTube video moments, clips, whatever. In case you're wondering how to get them, here is one. Just follow the QR code and it will get you there. So essentially just scan this QR code and you can mint this moment of this video. Easy as that. Let me demonstrate with the previous video. For instance, here the deep dive on Solana errors. Okay, so, here. There is a QR code in this video. And then I can take my phone and I'm going to use a wallet that I have synced. I have a wallet synced with my phone. I have it on my phone and there as well. And it's got nothing there yet. But, no, don't do it. No, okay. And then I just scan QR code, scan this. And essentially it comes up with this Solana Pay transaction. I hit approve. Because it's not a seed wallet, I don't even need to do anything. Perfect. That was sent, and now I will have that in my wallet. If we now look into our wallet here, then we got this moment minted into our wallet. Hey, what this transaction did here is not okay, right? Fun times. That's perfectly okay. But now if I go here and I connect this wallet, 0% loyalty. I can go to sell and see my inventory, and here it is, the 005, not okay. And It's so cool because you see all of the trades and everything here now. But anyway, I can go list it. I sell it for, I mean, I can't sell it anyway, but like 001. And if I execute, it says order complete without letting me sign. So that's the first thing that is like weird. And then if you have a closer look here, it says skipped. Possible causes, marketplace does not support, action already performed, or NFT no longer available. Or, and that is not in that list yet, the cNFT is just not supported. Why? Because it's not a very composable cNFT. Because I was cheap. When I set that up, I intended those NFTs to, just be collectibles and not have a use case or value whatsoever. So I didn't intend them to be tradable. But now that Tensor listed them, I'm like, well, I kind of want them to be tradable now, just for the culture. Because that makes them more interesting, right? And also just for me to play around with marketplaces, right? Anyway, yeah, that doesn't work, and I know why, because I had a chat with them. There. Tensor only supports proofs with a certain length. Otherwise, they can't fit all the accounts into one transaction. That's one of the limiting factors that we have on Solana. We need to specify all the accounts, and transactions have a certain size limit. That limits us in how long our proof can be, because our proof, if you remember in the state compression video, we basically just put the proof into the accounts. The proof hashes, we pretend they're public keys. And we have a certain limits in our transaction size. And in this nice table here, Tensor says those are the maximum length that we can support. And for the base case with 4 creators, that's a length of 14. If you also want to do collection bits, then for some reason that's way smaller. If you have 0 creators like mine, then this is the max proof length and this for collection bits. So essentially we need to get to a proof length of 9 if we want to, support collection bits, or 8 if we have 1 creator. I would imagine that it's not a 0 or 4, but there is everything in between, and for each creator that you have less, you save 1 account. Tensor can do custom lookup tables that saves you some accounts, and then those numbers get better. They can also shorten the name, symbol, and URI. That will also again save some space. But for my collection, they are not going to do that. And also, I don't even want them to do that, because then they would need to do it for your collection as well, and so on and so on. And that's just manual effort. So essentially, if I want Tensor to support my cNFT collection, then I need to make sure that my proof size is under a certain value. So now we can have a discussion about, well, what makes up this proof size and how can we shrink it? There's another great site that Nick made, compressed.app. I used to always forget until somebody reminded me yesterday. This app lets you quickly get an idea of how much SOL you need to pay for a certain amount of compressed NFTs. So for instance, if you want to mint 1 million, you could do so by paying 12,000 SOL if you use the uncompressed versions, although that's more now because Metaplex fees. When using the compressed NFTs, you could go down to 0.3 SOL in the cheapest version, plus about 5 SOL in transaction fees for actually minting them. But that's what my users pay anyway. So if you mint one, then I let you pay the transaction fee. So that's not something that I have to pay up front. For the tree, I would need to pay this. So the tree where my compressed NFTs are stored in. By the way, if that doesn't make any sense what I'm talking here, please watch the other video first for it to make any sense. I'm assuming that you have the background knowledge of how compressed NFTs work for this video. So I, of course, naturally went for the cheapest option, because I was like, yeah, I just want to pump out many cNFTs and don't do anything with them anyway. So I went with a canopy depth of 0. Remember what the canopy is? That's essentially a part of the proof that you store on chain. So the uppermost part of the tree, the Merkle tree, you store it on chain as well, such that we don't need to provide those hashes in our transaction. So in our proof, we don't need to have them in the proof, and therefore we don't need to put them in the transaction. That saves space, which is a limiting factor. That's the cheapest option. Then this app also gives me the option for uncompressed equivalent. So proof size of 3. That's the same as with a standard Metaplex NFT. So it's the uncompressed equivalent, because a standard Metaplex NFT also has 3 accounts: token account, metadata account, master edition account, in the minimum version when it's not a PNFT. So if I want it to be as composable as a normal NFT, then I would need to pay almost 60 Sol upfront. There's of course a middle ground. In this case, he's suggesting a canopy depth of 14, which makes a proof size of 6. And there we already see how the proof size is calculated. The proof size is the maximum depth minus the canopy depth. Because obviously the more I store in the canopy, the less I need to provide myself. With the canopy plus my proof size, I need to get to the max depth. So with a canopy depth of 14, that would be 7.6 Sol for the tree for a million NFTs. Which is not cheap, it's not super expensive, but also like 7 Sol is like, I don't want to pay that right now. But the proof size of 6 is still small. If we have a look here again, I essentially want to get to 18, or maybe if I feel like I want all those collection bits as well, then I'm going to go for 9. So I can make my canopy still 3 levels smaller, which will be a significant cost reduction. And unfortunately, this app does not let me specify my canopy depth. It just gives me those 3 options. I can play around with those numbers, right? I can be like, oh, I just want 100,000. It gives me random things like, well, here my proof size would be 0 essentially, so it's super composable. It's everything in the canopy, but I mean, why would you do that? Pretty sure there are use cases for that actually, but not the right thing for me, definitely not, too expensive. And what you can of course also do is just create several trees that are smaller. Instead of one big tree to mint all of your NFTs, you just create several trees that hold parts of your collection. And I think that's what I'm gonna do, because there's no reason to have all of the NFTs in one tree. So my goal is to get to a proof size of 9, and I want to know how much I have to pay for that. So, since we can't answer that question with this tool, let's do some digging ourselves. Because after all, this is a deep dive on cNFTs, and we want to know the difference. We want to find out what we really need to do, and we want to pay the minimum possible to get the maximum composability. Also, that said, this is just one marketplace, of course. Another marketplace might need a proof size of 8. And if I just go right for the 9, then I'm screwed with the other marketplace or whatever, right? Or another application. So the lower your proof size, the better, obviously. But also the more expensive. So I'm gonna aim for that 9, an 8 or a 9. And we can play around with this a little bit, because we can just create a lot of trees and see what happens. Cool, let's start the deep dive. Let's go dive in. SPL account compression has a function, get concurrent Merkle tree account size, which takes the max depth, the buffer size, and the canopy depth into account. There is also this depth size pair. Oh, there's all depth size pairs. Let's loop. Max depth, max buffer size. We start with a canopy depth of 0, and we're just gonna lock this and try it out. Then we should get all the depth size pairs with canopy 0 and their account sizes. So those are all the pairs: 3, 8, 5, 8, 14, and so on and so on. We've seen this before. With canopy size 0 all the time, gives me this size in bytes. Now that doesn't really help me much, because I don't want to know the size in bytes. Obviously, I want to know how much I have to pay for it. So let's find that out as well by getting the rent. And for that, I think I need a connection. Get minimum balance for rent exemption. There we go. Put in my size. Then I can also log the rent, which comes back in Lamperts probably. So I'm gonna divide it through Lamperts per sol. And damn it, I need to await this. So I need to make a function. But then I can't do, I mean, not quite what I want, but it will work now. We're not writing clean code, we're writing code that works. another thing that you can mint. You're welcome. Just moments, okay? All right, let's see if that works. There we go. That looks much better. Okay, so we have all of the pairs, all of the depth size pairs. They're now not properly sorted anymore because but we get all the values. With that depth and that max buffer size, we have to pay 0.01 for the tree. So without a canopy, if we wanted to get to a proof size of 9, then our max depth can be 9. There's only 5. And then the next bigger one is 14. Is that true, actually? Yep. We have 3, 5, and then there's 14. Because those things are all hard-coded into the account compression program. So you're not super free in what you're able to do because they need to treat it differently. So anyway, we don't want to get into that. But yeah. So if we want to get down to 9, best possibility is to take a tree of 14 and reduce it by 5 by using a canopy of 5. Let's improve upon our script and actually add canopies. For instance, we could say we want a certain max proof size. And then we calculate the canopy as our max depth minus the max proof size that we allow, because the rest we need to save in a canopy. And then we call it with, let's say, I really want a max proof size of 9. Run this again, and I get the following values. There we go. Unable to fetch minimum balance for rent exemption because, of course, I gotta max that. It can't be smaller than 0. There we go. No, still errors. Maybe it's too big of an account already. Kilobytes, megabytes, gigabytes. It's 136 megabytes. Yeah, I mean, that makes sense that you cannot. What's the biggest one? That would be just 10 megabytes, and there you can still calculate the rent. Yeah, because our accounts are limited. If you are trying to get 135 megabyte accounts, then that's not gonna work. Yeah, that's why we can't fetch the minimum balance for rent exemption. Account just too big, so this won't work anyway. But anyway, what we see here is how much we pay to get a proof size of 9. With 5 and 8, we're still under the proof size of 9, and we just pay the 0.01. With 14, we need a canopy of 5, and this is the part where it gets interesting. And here we would need to pay 0.23 sol. And if we allow for more concurrent writes, quicker updates, not 64 but 248, then it gets a lot bigger and we have to pay 6.9. So that's another factor that plays in there. Not just the proof size. Proof size is the same for that, but how many NFTs can be moved at the same time. And at the same time meaning from the point where the state change happened via the read API, updating that, the client reading that and putting that in their new proof and then sending that transaction again. Essentially, we can only be 64 steps behind, right? So 64 state transitions can have happened after the state of the tree that I have. If my state is even older than that, then I'm too late. But anyway, so this seems to be like some tree that I could be using, or one with depth 15. Then that's also just 0.26, and I have one depth more, therefore a deeper canopy. Doesn't make much difference to this one, does it? Then once we get like way bigger, 19, we can have a canopy of 10 and also just pay 0.75. So, I mean, this is a three-way trade-off. That's what makes this so complicated to pick a good value here, or to pick good values here, because it's a three-way trade-off. How many concurrent writes? How big is the proof size? And how many NFTs do I want to mint? And then it might just be better to have more trees, because that essentially then doubles that amount. Or like with more trees, I can have a lower buffer size, because if the load is split between several trees, then each single tree needs to support less concurrent writes. So there's so many trade-offs. And because I'm lazy in calculating, let's also add the number for how many NFTs that supports, which is essentially the max depth to the power of 2. No, 2 to the power of max depth, 2 to the power of max depth. How do you do the power of in TypeScript? This is gonna be unreadable, but I'm gonna do it anyway. I'm a dev, not a designer. I could at least print it with like thousands. A max depth of 3 just gives you 8 accounts. Proof size of 5 gives you 32. So the calculations are correct. And then the numbers get complicated. So I'm gonna do this. At depth 14 gives me 16k NFTs. So if I want like a 10k collection, then this could be a good strategy because that is still somewhat cheap. And again, I'm now working with a max proof size of 9. So therefore a canopy of 5. I could double my cost, take a max depth of 18 with the same composability. Well, way worse composability because obviously just one tree, more NFTs in one tree, less concurrency, not composability. Composability is always the same because max proof size of 9, therefore here just a bigger canopy. So essentially for half a sol, $10, I could already mint 260k. Here 0.3 sol, 65k. So there the difference from here to here is not that much, right? But the difference from here to here is quite a lot. Exponential. Those values go up exponentially, obviously, because we have 2 to the power of. The canopy cost also go up exponentially because they're also trees that are on chain, but they start smaller. So it's the same exponential function. It's always a 2 to the power of, but the NFTs we support, that's the number that goes up quicker minus the canopy that goes up later because there are 9 depths between essentially. So the exponential of the amount of NFTs I can mint in the tree is already increasing much faster because the values are already much higher than the canopy. But still, this stuff grows exponentially as well. So with a canopy of 10, we would have 0.75 and then 11, 1, 22. So it's not quite double because there's more stuff to it, like the buffer and stuff. And I don't know how it works internally, if you also need to design the canopy different if you have a different buffer size. But anyway, from here to here is almost a double, but not quite, because here you still pay for, other stuff, which is the same reason why I like smaller ones. The bigger the tree, the more the canopy falls into depth. And depth is probably the wrong one. The more percentage of the account size is for the canopy. Because again, the canopy increases exponentially. But then also it pretty much doubles if I have a bigger buffer size. So yeah, that also really plays a big role how big the buffer is. And it's super difficult to estimate that, how many people are gonna trade or whatever, use my NFTs at the same time. And I guess being conservative is better because it's easier to add new trees when you run out of space than to make the current trees more performant, because that's impossible. You can't make them more performant. Once we have a compressed NFT minted into one tree, then it's there, right? And that's my problem that I have now with my NFTs. They're in that tree. I can't get them in a new tree. I would need to mint new ones, airdrop them, and then invalidate the old ones or whatever. Don't know what I'm going to do about that yet. And since you can have several trees, which also improves concurrency, it's probably a better strategy to go with several smaller trees. And again, I can't tell you what the perfect values for this are. I can just tell you how you can calculate all of this and what implications it has. Then it depends on your use case. And eventually we will, the community will find a standard or whatever that most collections go by. And when they go by that standard, then they're supported by most of the marketplaces and applications that allow for the usage of compressed NFTs. I don't know what that's going to be. I mean, the application is mainly limited by maximum proof size, and then how many can work at the same time without failing. That is then dependent on the buffer size as well, / how many trees you're actually using. So yeah, super complicated, but I hope that I can shed some light on what goes into deciding which tree to use for your compressed NFTs. If I want a collection for 1 million, here for 1 million, I could do this one, 20 for 10 sol, or I'd take a cheaper one, 20, or even with this one, then it's just 1.2. And that already also supports a million. 1.2 versus the 0.3 that I paid just for, you know, a canopy of 11. I will probably go with something small for the start. 32K. I mean, 32K should get me a long way. So far, only 130 NFTs were minted from the 1 million that I have space for. So 32K should be sufficient. And I pay a fourth of a sol for it, like $5. Let's do that. Did we decide for max proof size of 9? Or do we want to go with creators and have a max proof size of 5? Or do I go 8 and put 1 creator or something? Let's see, if I were to calculate for 5, max proof size is 5. What would I need to pay? Yeah, at the lower ones, that's way too expensive or way too big. So for 13K, I would now need to pay 0.69. I mean, that's, I don't know, $15 or something. No, we're gonna first try it with a proof size of 9. Or how about 8? So then if I want 32K, I could pay just this. I think that's what I'm gonna do. I mean, but from here to here is also not that much different. So maybe do that, why not? 16, then 17 would be 0.5 for 1. Yeah, this one looks good. Let's take that. So a depth of 16, which allows for 65,000 NFTs with a minimum buffer size of 64. Like, I don't expect a lot of people to trade this collection like quickly. So, but then I also didn't expect them to trade my collection at all. So maybe that's a wrong assumption here as well. Or should I just do more smaller trees? But what would be my possibility for smaller trees? Like a 14 with that would also already cost me 0.25. So I mean, that, like, the cost difference from here to here is almost insignificant. And like, I have like 4 times as many NFTs, but like the cost is like not even double. So yeah, this one, like, just by looking at numbers, this one seems like a good choice. So again, 65K minimum buffer size, therefore a canopy of 8 to allow a proof size of 8, because 16 minus 8 is 8. Costs me this. And I think I can afford that. So yeah, that's what we're gonna do. We're gonna use those values. Let's go. So let's have a look at how we can create a tree with a canopy for the Bubblegum program. Because last time we did the video on cNFTs, we were not using a canopy. And even here, I'm not using a canopy. I'm just using this pair, and then I create that account, and that's that. Now, here is the important thing that I recently learned. The Bubblegum program does not care about your canopy. When I create the tree with this create tree instruction, I don't need to provide which canopy I want to use. I just provide the tree. Wait, that's the creator. Where's the tree? The Merkle tree. I just provide the Merkle tree. But the Merkle tree is owned by the SBL account compression program. And the SBL account compression program will define the canopy size based on how much space is in the account. So I don't need to provide like more information. I don't need to say how much my canopy should be. I just need to allow for enough space such that the SBL account compression program can defer which canopy size it can use in that space. That's how it works. At least I was told so. So today we're gonna try out if that's actually the case. So essentially all I need to change is in my space requirement here with the get concurrent Merkle tree account size, I specify the canopy depth as well. Canopy depth I said was 8, and I use the following pair as 16, 16, 64. And then we have the 16 minus the canopy depth of 8 gives us a proof size of 8. Because in my previous tree I had a proof size of 20, which is too big for Tensor. Okay, and then we're just gonna run this script. Wait, actually, how much sol do I still have? Not that much. So I need to top up my sol. Meanwhile, get a new address for the tree. compressed tree. Cool. We have a C tree. Nice. And we now have 0.42 sol. So we put that tree here and we added the canopy depth and the rest stays the same. And I'm just gonna mint myself this tree. Do you mint a tree? No, you create a tree. Create composable tree. Let's see. I hope that works. Yes. Okay, we paid a little more than the 0.36 that I calculated. In fact, let's just look at the transaction. How much did I have before? 0.6? Yeah, just a tiny little bit more. Yeah, 0.366. I ignored the part here. Yeah, so 364 and I paid 366 because 364 is for the tree. So that's correct. The tree got that size, but then the XC, whatever that is, also required some. What is that? Oh, yeah, that's the bubblegum. Right, the bubblegum config or whatever that was. Yeah, got it. Okay, cool. So we've got a tree with a canopy. Now we just need to change my minting script to use that tree. Solandy cNFT minting service. That's yet another program. Create mint cNFT instruction. It's the tree. Okay, so I just replaced this with my new tree. The authority is the same. I still have the same authority. So I should just be able to now mint into this tree. Git commit, change tree to a more composable one with a proof size of 8. Then we push this. Then that's automatically directly building in my Versal app. I love this. This is amazing. I love it. I don't need to do anything. It's just deploying automatically. Testing in production. That's how we do. Ready. Now, let's mint ourselves another thing, but maybe not the same one, but a different one. Can we find another one in here? I can also cheat and put this here, but I don't want to show you, obviously, because you gotta watch the other video. I won't let you scan it like this. But me, I am gonna scan it like this. Boom, and then I'm gonna approve this. Sending, cool. Which means that I should now, yes, have another one in here. Sometimes it works, sometimes it doesn't. This time it worked. Coming back to here, I have the two of them. So we have the sometimes it works. This one is the one that I just minted. Can I go list this for 0.01 execute transaction? Damn it! No, I can't. Still not. Why? Because the proof size should now definitely be smaller. Maybe there's something else that is going wrong here. But let's double check that this one was actually minted in the new tree. So, yep. It was definitely using the compressed tree. Composable tree. Whatever I called it. The C tree. So it's definitely in this tree now. That guy definitely has a proof size of 8. Let's check that, if it actually has a proof size of 8. Who wants a cNFT? Sure, Richard wants one. Sometimes send to Richard, send one NFT. It even says NFT to. Okay, let's go. Wow, I had to pay a lot. Oh yeah, that's software. So, there we see them. Yep, 8, even though maybe it's even 7 because the system program is one of the remaining accounts here. Don't ask me why that is the case. Maybe the proof is just all zeros because there are none minted there yet. I don't know. In any case, we provide 8 values, 8 hashes for the proof as compared to the 20 that I would otherwise use. Who else wants one? Exception. You get the other one. And thank you for the kind words. So the other one that we minted before, if I send that, this one will have 20 remaining accounts. Yep, there, 20 remaining accounts because there is no canopy in this account. So the thing with the canopy works. We did the thing that we wanted to, and there might just be another bug with Tensor why it doesn't work. Because according to their table, if I have a proof size of 8, I mean, I'm just trying to list. I'm not even trying to do anything more complicated here. And even if I had 4 creators, 14 should be supported. So I guess I need to talk to the Tensor guys. Good thing though, they are very responsive. Probably even on a Saturday. But we can still end this video here. Yeah, we achieved the thing that we wanted to do. We managed to create a cNFT tree with a canopy. It's really that easy. It's really that easy. You just need to add the size to the space requirement for the account that you create, that then the Bubblegum program will assign to the SPL. No, actually, I assign it there, but then the Bubblegum program will use it. The Bubblegum program will initiate it. Oh, while we're talking about it, he's literally texting me as we speak. He updated the name. I suspect I know what's the issue. There we go. It's now called Solandy Clips. See, those guys are just serial shippers. I mean, that's amazing. That's amazing. It's just so cool. So cool. And we can also refresh that because my inventory is now empty. I'm gonna mint myself another one. But it's easy to mint myself another one. Since he's already saying he knows what the issue is, or he thinks he knows what the issue is, they will probably fix it soon. It's a few hours later now, and after a bit of back and forth with the Tensor guys, we found the error. It's actually my fault. More on that later. Wow, wait, I need to give the recording priority. So, let's see if they actually fixed it. I list for like 1 sol because YOLO. Then it says signing and it doesn't immediately crash. And it opens my wallet. Oh, this is getting exciting here. And then, that's probably for an account or whatever. Classic Tensor. And it's listed. The first one is listed. Look. Floor price 1 sol. Stupid, but true. Nice. There we go. For 1.03 sol, you can buy the thing that you could also mint for free. But you could buy it here. Not financial advice. So they fixed it. It's working now. We still need to discuss what was wrong. But the problem with them shipping so fast is that I couldn't even tell them, please don't ship it. It was already pushed to production. Anyway, I gotta tell them it works for me. Let's discuss what was going wrong. The issue was that the hash wasn't matching. So apparently they didn't have the right data that is on chain. Like when I created the NFT, wasn't the same, wasn't matching to what they had as information. So the data didn't match, so the hash was different. So the whole thing just didn't work. And after some back and forth, we figured out the issue was this here. That I set token standard to null. In that previous video, I'm pretty sure I was like, I don't know what goes here. Can I put null?
Can I put null? Token standard. Can I put null?
And I did put null and it didn't break. So I was like, yeah, null is fine. But token standard is actually an enum. So null is probably a bad idea for that enum because they were using 0. I'm using null, which makes it different and therefore not work. Now they fixed it for me. They changed for my collection that it's using null now, but that's inconvenient because people should not copy my code because I want to fix that. And the problem is if I fix it, then it's not going to work again. So token standard is the token standard. So yeah, I should put something there and not null, right? Is it a fungible? Is it a fungible asset? Is it non-fungible? It is a, well, what is it really? Actually, it would be an asset because I have several of the same one, right? But let's say it's a non-fungible. 0. I'm gonna put this here instead of my null, my beautiful null, and I'm gonna fix it. And then I'm gonna push to production. This is ridiculous. I mean, I love it that he's like so fast and pushing it out, but he's too fast. I'm like, no, please don't. And he's just pushing. What? No, don't. I want to have it the right way. Anyway, I could just say, oh, it works, it's fine. But no, I'm not happy with that. I wanna do it right. Anyway, so fixing token standard is live, which means we gotta mint ourselves another NFT, now an actual non-fungible. Let's take the hey not okay. Because really what we did here is not okay. Yeah, it was using the wrong token standard, damn it. Now we're using the right token standard, but now I think it's broken again. Not okay. Can I list this? For 0.1 sol. Yes, I'm intentionally listing 90% below floor. What, this is also working now? Did they do a fix that actually allows me to... Maybe he did the fix general enough that it now works with all of that, whatever I put in there, which would be great. And it looks like that's actually the case, because I was able to just list this. Amazing! The Tensor guys are ahead of me. I was like, don't push it. And they're like, well, don't you worry, we push something that works in any case. God damn it, they're good. Still not a sponsor of this video, but I'm impressed by their work. On a Saturday evening. Don't they have lives? Don't I have lives? Nah, who needs lives if you have NFT collections? Yeah, but that's cool though. It's so cool that because now I can play around with NFT collections and list them for 001, 99% below floor. It's way too much fun. I'm enjoying this way too much. Hey, I'm just testing here. I'm just testing if it works. Like the sol I'm putting in there to list them is worth a lot more than the NFTs themselves, but that's a whole different story. But now that works. Isn't that freaking amazing? And then I have one more that is the same as this one. I'm just gonna sell this one against myself. Yep, and I'm getting 0.00081 because fees. We gotta pay Tensor. They're doing good work. Order complete. I sold my first NFT against myself, so I didn't really sell it, but like, nice. Just proving that this works. Now, coming back to making it not work, because those were now all with the new tree, right? Let's go back to our issue from the very beginning, where we had the 20 proof size tree. We will mint into a different tree. There. Now I need to mint myself the you get it after it has been built and deployed, which is super quick. I love it. Ready. Now, boom, and tink, tink, tink. Do you get what I'm saying? You get what I'm saying? Of course you get what I'm saying. Right? Super simple, right? Super simple. You get it. I love this. I'm having fun. If nobody else is having fun with those things, I'm having fun with them, okay? Good enough for me. You get it? If I now try to list this one, because this is in a different tree, and I execute this, that still seems to work. I'm gonna sell it directly. Aha! Okay, so the selling doesn't work. Apparently for the selling, it is too big. I can't do a market sell, as I would be able to do with all of those, right? I could do the... Yeah, my computer's a bit slow because I'm recording and everything. Okay, in 2 transactions. Oh, and then actually this one seems to fail. Let's see, let's approve this. Also goes through, just didn't simulate correctly. Well, it didn't simulate correctly, obviously, because it wasn't delisted yet, so it didn't have the right state, so then it didn't simulate. So, but yeah, 2 transactions. Yeah, makes sense. Okay, cool. So that works. With those NFTs, I can't just sell them. This one, I can't, because... probably the tree is too big. But I can list it. Listing I can still do. That would actually be cool if I can also buy them, because then I don't need to change anything. Then I just leave them in the old tree. And yeah, here we see it. We used 30 of the 32 accounts. Yep, close. Yep. It's a proof size of 20. And it still works. Just about. Now, can I also buy this one? In their docs, they say they don't support it with those few accounts, but it seems to work. Also, just because I don't have any creators. If I had creators as well, then I would be screwed. Look, this is cheap. I'm paying more network fee. I approve this. Nice. Good to know. Good to know. Even in my shitty tree, I can list and buy. I mean, that's good enough. then we don't need to change anything. I still, from now on, will mint into the new tree. So for newer NFTs, you can do market sales now. This is fun playing around with this. Been a long day, been a long and exciting day. Tradable compressed NFTs. Brought to you by Tensor. Still not a sponsor. Coming back to my collection. Here's the thing. We can have a look at the trades and everything. This is so fun. I love to do this. You can, sort by the date or the mint time. And that's one thing that I want to discuss with you right now. I have these 3 rarities: legendary, rare, and normal. In my terminology, the mint time is early, the first 24 hours, on time, first week, or late, anytime after the first week. So the late, I like it. It's like black and white. You still have the same clip, but it comes out black and white. If you're not watching a recent video, but one that I published like a longer time ago, this one for instance, if I mint myself this one, then it will come out black and white. Deep into the tech. The picture and the video are black and white. And I kind of like this. Because if you're too late, you just get the black and white word. But here's my thing now. I'm not a fan of this goldenish yellow. It kind of looks more piss yellow than golden. But I had to find some way to make the legendary one different from the normal one. And I kind of like the normal one. Now my question is, do I put the normal one as the early one? So only if you mint in the first 24 hours will you get the nice looking one. But then what do I do for on time? I don't know. I'm not sure. Do I just not support early minting anymore? But I also kind of like that. I want you to get something special for watching it early. But this kind of feels like I'm making it worse than the on time one. Like me personally, I would prefer the one with natural colors in my wallet than this ugly one, even though this one is supposed to be rarer. So I'm not sure about that. What do you think? What do you want me to do in this case? Do you have any other ideas? Should I just use a different filter? Something, any ideas for like what it should be something easy because it's already a lot of work to do them for each video. And then I usually have like 3 or 4 per video. Yeah, so let me know what you would prefer here. Or maybe I just have it, maybe I put a longer clip or something like that. I don't know. What do you think? I don't like the piss yellow so much. Now that I have a proper collection on a proper marketplace, I kind of want to, have it look good. But they still have all value none. But hey, who knows? Somebody is already bidding. I'm telling you, it's myself. I'm bidding. Just to test. Oh yeah, now I have 100% loyalty. So let me know what you prefer in the comments below or in a Twitter poll that I will totally make when I release this video. Speaking of, follow me on Twitter. Hey, here. You can click here and get to my Twitter. Yes, look at that. And you can click here and get to my YouTube. Thank you for watching. We've got exciting times ahead of us. At least for me. My collection is tradable, not yet, but soon tradable on Tensor. Probably when this video is out, it will be tradable. I hope that you learned something about compressed NFTs today and can now make better decisions of which tree to use. It's really hard to tell by now, but I would recommend a proof size below 10. I mean, unless you drip and you're literally tripping millions, but even if you do that, then you can still just use several trees. So yeah, depends on your use case. It's just like we still need a bit more time to figure out like how big of proof sizes applications actually support. Obviously, if you want to have several cNFTs in one transaction, then it's even gonna be worse. So the smaller your proof size, the better. And it's not that expensive to add a canopy, especially with smaller trees. So I would recommend that to also add canopies to your trees for the account compression program. But again, the exact values, I can't really give you good advice. I can just tell you what the consequences are, but I can't tell you what programs need yet. Because I also made the mistake of, putting those NFTs in a tree where they would fit 1 million without a canopy. So that's cheap. That other tree with 1 million was as cheap as the tree I just minted now for 64k NFTs, but it's less composable. so I can't use that collection on Tensor, or that those elements in that tree, because it's still the same collection, but some of them are tradable and some are not. And here we are back full circle to what I said in the beginning. A cNFT doesn't equal a cNFT. Some are in better trees. That's what I want you to take away from this video, such that you can make informed decisions of which tree you mint your cNFT in. That's a mouthful. As I said, I'm gonna have the Tensor guys fix this, but they are so pro, they're on this, they'll get it to work eventually. Meanwhile, you can watch those videos, like and subscribe, and then I will see you in the next one for more Solana development content. Till then, bye bye. Also, don't trade my NFTs on Tensor. I have to advise you against it. But you're a DJ, so I can't tell you what to do. Ha!